वेलकम टू आवर चैनल बी ऑलवेज लर्नर। इस वीडियो में हम डिफरेंशिएशन प्रॉपर्टी इन टाइम कवर करेंगे जो कि फोरियर ट्रांसफॉर्म की प्रॉपर्टी है। आपको वीडियो पसंद आएगा, आप लाइक करिए, शेयर करिए, चैनल को सब्सक्राइब करिए और बेल बटन दबाना ना भूलिएगा। डिफरेंशिएशन प्रॉपर्टी इन टाइम results in multiplication of Fourier transform by j omega. So the property is, if by definition I can say the Fourier transform of xt is equal to capital J omega, then I can write that derivative, or I can say the time derivative of x, this is a function of time. अगर हम इसका फोरियर ट्रांसफॉर्म लेते हैं, सो दैट इज इक्वल टू j ओमेगा कैपिटल X j ओमेगा. That is what it is, and we have to cover the proof of that also. So we know by definition that xt is inverse Fourier transform is given by the equation. By definition we can write by this d omega. Now we can have the derivative both side. We can have d by time derivative of x is equal to 1 by 2 pi integration minus infinity to infinity x j omega. Now the d by dt of e raised to power j omega d omega. So that is a function, only function which is a function of time, the entire right side equation. Now the derivative of this term will be minus infinity x j omega. Derivative of this term will comes out to be j omega multiplied by e raised to power j omega and time d omega. Right? So which can yield the equation, the time derivative of xt, that is equal to 1 by 2 pi multiplied by j omega integration minus infinity to infinity x j omega and e raised to power j omega t d omega. Now this, by definition I can write that the Fourier transform of the time derivative of dx by dt, that is equal to, this term is equal to what? This term is equal to x j omega, and this term will be equal to x j, now multiplied by j omega. So similarly, if I am going to take the nth time derivative of xt, that will be equal to the j omega raised to the power n x j omega, x j omega. So that is the property and that is the proof of the property. आपको ये वीडियो पसंद आया होगा, आप इसे लाइक करिएगा, शेयर करिएगा, चैनल को सब्सक्राइब करिए।